Okay, some people asked for some help with the show you know on page, this is the show you know on page 59. And it says a hot air balloon climbed 0.8 meters per second for 10 seconds. So it went up 0.8 meters per second for a total of 10 seconds. Okay, that means that it went up less than a meter per second, right? So if you were to think of a meter stick and you were to go stepping one second at a time, you would go just slightly less than a meter per step for 10 seconds. Not very far, not very fast either. And then it descended, it went down, that's what descended means. It descended 0.6 meters per second for 6 seconds, less time. This is what was the overall change in altitude. Now for this particular question, it's probably best that we use a number line here to see how this works. We'll just use an actual picture to represent it. So if I was to go up 0.8 meters per second for 10 seconds, what operation would I use to calculate the total distance I went up? Well, hopefully by now you do not do 0.8 plus 0.8 plus 0.8 plus 0.8, etc., but you realize this is actually a multiplication question. 0.8 times 10. And again, we're going to use the brackets to represent multiplication. And what is it when you multiply by 10? Well, you simply move the decimal one place over. So what's my answer? It's 8. 8 what? 8 meters is how far I went up. So in the first 10 seconds, I went up 8 meters. So I'll represent that here on my number line. And we'll start 0 right here. So I went up 1, 2, 3, 4, 5, 6, 7, 8. I went up 8 meters. And then I went down 0.6 meters for 6 seconds. Again, the same process happens. So what is 0.6 times 6? Well, this time I can't use my little trick of moving the decimals. I actually have to do the calculation. So 0.6 multiplied by 6. 6 times 6 is 36, carry my 3. 6 times 0 is 0. Plus 3 is 3. What would be my estimation of half of 6? Well, roughly decimal 3.6 would be roughly half of it, right? So 3.6 is my answer. So that means I go down 3.6. So down to 7, down to 6, down to 5, and another decimal 6, down to 4.4 is where I'd be. That's between 3 and 4, between 5 and 4, between 5 and 4. I'll just put that there first. But how do I get my actual answer? Okay, hold on, I better put this down in here. So we went, I'll erase this. We went down 3.6 meters. And notice how I'm going to express the down with a negative symbol. I'm not going to actually, I'm going to use down negative 3.6 meters. So overall, how do I figure out how high I am? Well, if I take 8 and add negative 3.6, that will give me my answer. So let's do that. Let's take 8. So what do I have more, positives and negatives? Well, I have more positives. How many more do I have? Well, I have to find the difference between them to figure out how many more do I have of it. So if I subtract them, that will tell me how many more of the positives I have than the negatives. And I have to borrow here, and I take 10. I have 4, and I have 4. So how many more positives than negatives? I have 4.4 more positives, which is my answer. And I think I said that over here. I said it was between 5 and 4, and that's the answer. If I go on to the next part, it says, what is the average rate of change in altitude? Well, the average rate of change, let's go back here for a second. So over the course of 16 seconds, if you take away the whole 16 seconds and you started on the ground, how far did it go up in total? Well, we found out that it only went up, in total, it only went up 4.4 meters off the ground, right? That's how far it went up in 16 seconds. So in 16 seconds, it went 4.4 meters off the ground. Well, how does that help me figure out the average? Well, the average means per second, how far did it go over? So if I set this up, I could actually set this up as a rate. It went 4.4 meters per 16 seconds. This is what we call a rate. If you remember from grade 8 math, this is called a rate. And then I can get it into a unit rate, right? Rate, by making the second term 1 second. I can figure out how far it went in 1 second, and that will actually also calculate the average. So if I divide both first and second term by 16, I'm actually creating this unit rate, figuring out how far in meters per second it went. If it went 4.4 meters in 16 seconds, I can quite easily figure out how far it went in 1 second. And if I take my calculator and go 4.4 divided by 16, it tells me it was 0.275. So it was 0.275 meters per second. And if I want to figure out the average, therefore, I can use my therefore symbol. By the way, how many centimeters is that? It went 27.5 centimeters per second. That was the average rate of speed that or the average rate of change in altitude that the balloon went. Hopefully that helped you and not confused you. And if you have any questions, come see me.